system, especially for anything user space, especially for anything else. And so we have to live in IDA, Hydra, all those, and decompile all these and figure out, all right, what are you doing? And so, for example, we have to reverse engineer the 302 LLVM and metal graphics stack, OpenGL graphics, the TV and security chip, IO 802.11 and Broadcom, and so on and so forth. And so even though we had neat tricks for those first three issues, unfortunately, injecting frameworks dynamically is very difficult. So instead, we actually have to patch the root volume that your machine's booting to add those back in, either patched binaries or just downgraded or ones that were missing. So now let's look at the T1 security chip. It was actually dropped in macOS Sonoma just this year in June. The basic idea of the T1 security chip is that it was released in 2016 as Apple's first foray into a coprocessor for their Macs. It drove the camera, touch bar, touch ID, all those fun things, and it was based off the Apple Watch Series 2. But the problem with Sonoma is that it broke communication with this chip. Specifically, it could sometimes see the chip in some areas, but when it tried to send data, it wouldn't get any back. And same vice versa. T1 would try to communicate with the operating system, but it doesn't want to. And so we had multiple areas we need to fix. Of course, the main one was kernel side, where communication is done over USB through kernel relay host. But there's a whole bunch of kernel extensions that remove the logic for communicating with this kernel extension. So we need to downgrade Port Crypto, Apple SSE, Apple Keystore, and so on. And then in the user space, we have a whole bunch of frameworks and binaries that either were removed or the logic for those frameworks were strict. So for example, embedded OS install framework, outright removed this year. But local authentication framework, biometrics D daemon, and so on, they're all still there, but they don't have the logic to actually speak with that old framework that was ripped out. So to fix this, in the kernel side, we're going to use OpenCore package, as we did with boot.efi editing. We're now going to edit the kernel cache right before the machine boots. So we're going to inject those old kernel extensions. And then for the user side, we got all those frameworks and binaries. We're going to patch them in with OpenCore Legacy Patcher, the Python front end, onto the root wall. And from there, it mostly works. So there's also some other neat tricks we're doing. We're also developing a ton of kernel extensions that are editing data as it's being paged in from memory, using the being paged in from disk into memory using the Lulu patching engine. For example, we have feature unlock.kext that's going to listen through for when memory is being paged in and see, hey, are there any model checks that are arbitrary? For example, AirPlay to Mac is limited to 2018 and newer. Sidecar is 2016 and newer. Continuity camera is 2017 and newer. Well, with feature unlock, we can find those and strip those requirements out of it because they're actually just arbitrary. They just want you to buy a newer Mac. We also have Cryptex Fixup, which is using Apple's translation system, Rosetta 2, to actually run our really old machines, thanks to compatibility binaries that are available in the operating system for Rosetta. We also have user space daemons that try to help repair macOS after OS updates, as it's not too much of a fan of what we're doing and tries to clean up a lot of our work. So why do we need all these tools? This slide is basically just a clarification of a whole bunch of weird words I just said. So in OpenCore package, it's a bootloader your machine boots into before it boots macOS. This is going to patch out early checks in the operating system, like boot.efi, and add additional kernel drivers that we may want. All right, then we have the kernel running. So we have Lulu that's going to patch in memory while it's running along the kernel and allow plugins to do whatever it wants. So this is where it restricts events and feature unlock them. And then finally, in disk or on disk and in user space, we have the Python front end that'll add files to different areas. Additionally, it'll also add to kernel caches that may not fit in the first one. That would be OpenCore package. macOS has 3 kernel caches that are loaded at different stages in the OS. So let's put all the pieces together. How does it actually boot? So ignoring this overly complicated diagram, the basic idea is that your Mac powers on. It's going to search for file systems that it sees, that it recognizes, look for bootloaders on those file systems, and then it's going to load them. So it'll load open core package for us, and then it's going to do its magic. One really neat trick we're doing with 5K and 4K iMacs is we're actually hiding through Apple's diagnostics tooling. What this does is actually retain Apple's signature, so it still thinks it's genuine and not a third-party operating system. What this does is unlock some additional features that normally would be locked out, like the dual DisplayPort timing controller that made the 5K iMac possible back in 2014. So now we have OpenCore load boot.efi into memory, Apple's bootloader, and does whatever it needs. So it'll patch out platform support.plist and do extra magic. Then it's going to load the kernel cache, the boot kernel collection, the first stage cache, into memory and do whatever patching it needs. It might patch a bit of the kernel, it might remove kernel extensions that are incompatible, or even add other ones such as Lilu and its plugins. So now OpenCore package is done its magic, and we'll see macOS boot. So of course, boot.efi will start up and look for that malformed file. Oh, can't find it? Continue on. Then it's going to bootstrap the kernel and let that run. It's going to set up all the memory regions, it's going to do all its magic, and then start up additional kernel extensions. The early stage ones are going to be ACPI, PCI, so on and so forth. And then finally, general kernel extensions can load. This is where Lilu and restrict events and all those fun ones come in. So they're going to load up, and restrict events is going to do its magic and hook onto the kernel. It's going to reroute the value depending on what's happening and continue on. Then user space will start to kick in, and then the second stage kernel collection, the system kernel collection, will start up. This holds audio and graphics, just the general stuff there. Mainly ones that are not required to boot, but are still needed there for a useful experience. So then let's look at how user space starts up. We have the very first user space binary in macOS, launch D startup, and this is going to load the dlid shared cache. What this file is in a sense a giant blob of tons of frameworks in macOS all merged into one. This is where feature unlock is actually listening in for when it's being paged in from disk into memory. It's going to look and see, hey, I see AirPlay support.framework. Hey, you have that arbitrary model check. Rip it out. And then it loads in. And then we have our general frameworks and libraries, additional ones we patched using Python frontend. And then we have the third stage kernel cache loading, the auxiliary kernel collection. This holds third-party device drivers, as well as anything that we might not have been able to patch in earlier as easily. Finally, you have Windows Server kick in, the graphical user interface. Okay, but is Apple really letting us do all this stuff? It seems a little sketchy. Surprisingly, they don't mind for the most part, at least on macOS. They have been reluctant, but they still allow a lot of configuration in the operating system. So as I mentioned early on, every major macOS update generally changes something about the security architecture of the platform. Every other year is major changes, and then the other ones are minor. However, every time a new security feature is added, there's generally been some way to lower it, disable it, or bypass it from the end users. However, as Macs have become more iOS-like, there have been genuine concerns that Apple might lock this down in the future. But funny enough, at WWDC 2020, Apple Silicon Macs were shown to still be just as configurable. We can still configure secure boot, group volume authentication, system integrity protection, and so on. Of course, they're pivoting this towards researchers and hobbyists, but we kind of count as hobbyists. And so, as of right now, zero threats from Apple. However, it's not all perfect. macOS patchers in general, not just OpenCore legacy patchers, you're basically leasing it for your machine. And so every year, there'll be drastic changes. Even mid-cycle, month to month, there might be drastic changes that you might not realize that'll hurt your machine. You're also developing just a closed source operating system. Even though parts of the X and U are open source, the majority of it is not, or at least that we care about. For example, the virtualization stack on Apple Silicon, outright missing in the open source kernel.
No.
And so 95% of our reverse engineering and understanding what is macOS doing. So it requires a lot of skilled developers with deep understanding of macOS, some background in software assemblers, hopefully. And also to restore hardware support, you unfortunately need to lower some security features. We were patching in frameworks onto disk. It means we got to lower the file system protections to allow our files. You're also expecting a small group of hobbyists to maintain the same level of work as a trillion-dollar company. That's not possible. So then, there we go. So then let's look at how macOS patchers have affected the world. So they, of course, allow machines to be used longer, reducing unnecessary e-waste. And they also allow lower-income families to keep their machines around longer and not buy new hardware when they're not ready. For example, if the latest Adobe Acrobat suite requires you to install the latest version of macOS, that doesn't mean your machine becomes suddenly obsolete because you can't use it for class. There are still ways to get the machine running longer. If we look at Brazil, they're the third largest user base of open core legacy patcher, just due to the challenges of affording new hardware. So for example, the iPhone 15 is almost double the price in Brazil than in the United States. If we look at this pie chart here, we started recording a somewhat anonymous data on where users are that are using our products. And what's really interesting is, even though we still have a large chunk of the US, or our user base is of the US, it's not predominant. It's actually very well distributed for what you'd expect. So of course, 22% US, 10% Germany, 6% Brazil, 5% UK, 4% France, 3% China, and so on and so forth. And what this shows is that not just third world countries and not just first world countries want to have their machines last longer. Everyone wants their machine to last longer. So then Apple and the environment. Every keynote, they're always talking about recycled aluminum, how much they care about the environment, so on and so forth. But by letting these machines go obsolete, they're adding to the landfill. If we look at Google, they are now going to be supporting.
Oh, sorry.
No, it's all good.
We're trying to fix audio online. They're not getting any audio, unfortunately. Why did that cut video go?
Oh, yeah.
Oh, there we go. Now,
That's actually a really good point. I do believe that regulation can help with this, because Apple's not going to just suddenly have goodness in their heart and extend life of these machines for an extra 7 years. They do need to be forced. And so regulation is actually a good example. In California, they have a bill where machines have to be repairable for 7 years. They have to be parts of refund for that long. I think it might have to be more. I need to double check. But that's where legislation helps the end user, because they could still buy parts for the machine. Oh. And so another thing to keep in mind is services users, they're being left behind. You can't use all those fancy iPlus features coming out of the new OS. So what's the point of paying those money? Another thing that's really important is some people try to defend Apple by saying, oh, it's really hard to develop an operating system. It just supports so many machines. They're a $1 trillion company. But then let's look at the flip side. By keeping older machines around longer, you're unfortunately keeping foldable machines in the workplace and in environments. For example, that includes both hardware vulnerabilities like on Intel CPUs with Spectre and Meltdown, as well as like the T2 security chip that Apple developed with Checkmate. Also, there's software issues. For example, on pre-T2 machines, they don't support security. And so Mikey Jin has a really cool exploit that objected by the CP 6.0, where he was able to just swap the kernel cache for something malicious without much issue. And also, by having more machines around, you're having more hardware drivers. And a lot of drivers still sit in kernel space. And that means more vectors of attack. Another thing to keep in mind is by keeping these old machines around, you're keeping fallback code around. And so for a lot of machines, they might not be able to be used to their full potential. For example, there is the lack of hardware device attestation for machines on pre-T1 machines. So if you run a mobile device management instance and you need to verify if your machine is genuine and someone's not spoofing it, well, you still need to have fallback code to say, oh, well, that machine might just be an old pre-T2 machine.
Devices, nothing.
So then, in conclusion, older operating systems just don't last as long. They get a couple of years of shelf life. And of course, they leave you vulnerable if you sit on them. Also, Macs are dying at a quicker rate, and we don't know if this is temporary. Of course, Apple Silicon might be accelerating the process, but does that mean that it's going to be 5 years after Intel's gone and we're just on Apple Silicon? We don't know. And so, unfortunately, to get more life out of your machine, you have to either install a third-party operating system like Windows or turn to Hossy's products. Apple's going to give you no love. And by doing all this, by leaving these machines abandoned, they're contributing to their carbon footprint. And before I finish up, I just want to thank so many amazing projects, developers, and community members that are helping. Are doing amazing work. Otherwise, it's Q&A. Thank you so much for listening to me ramble. Top link is Open Core Legacy Patcher. Other stuff is personal info if you care. Oh, I am fortunately an Apple simp, so I do not have a good explanation for that, unfortunately. Sorry. Yes. At least for how I see it is a lot of people buy Mac to run macOS. When it no longer can run macOS, they want to throw it out. They want to get a new machine. So by being able to still run macOS for longer, it keeps those machines alive for those users. Of course, yeah, Windows and Linux, like installing either of those are probably the better bets for long term. But of course, it's a third-party operating system. You're gambling with the OS vendor of they're going to be maintaining support for your machine. Like Linux is mostly a community project. So once Apple strips that x86 code from the operating system, there's nothing we can really do, unfortunately. Of course, if Rosetta, so Apple's translation system, if it's kept around, funny enough, we actually have a very good path forward with that for the most part. But that's gambling a lot on an OS vendor who doesn't really care about us. They just care about keeping their machines going.
This actually goes back to how Apple made Secure Boot and a lot of security features configurable on Apple Silicon Macs. That what allows a lot of hobbyists and researchers to do what they want. But iOS devices don't have that. There is a security research program that they give a very few iPhones to very select few individuals. So unfortunately, for the most part, there is very little chance unless you can find a jailbreak to get running. And also, I can't comment on if iPhones are dying quicker as well, but I do see that overall they're not lasting as long as they should. So our user base, hopefully for the most part, is personal devices. I'm terrified to think about people deploying this in enterprise. Unfortunately, I do know people are deploying this in enterprise to meet security compliance to get on the latest OS. That's terrifying. I don't want to think about that. So for how you actually find this project, most of the time it's literally, I want to install Microsoft Ventura on my Mac. It'll show up on GitHub and you find our guide. There's a whole bunch of YouTube videos. Like the community really loves the project overall. And so they love to make documentation. They love to help. We have a community Discord server where people pop in and ask questions and so forth. Oh, I don't know if I want to talk about that. It's basically we have some machines on hand. So of course we're reverse engineering. We're just doing small testing on ourselves, like our own machines that we can figure out. And then for the most part, we have public betas. People will chime in if there's issues. We try to see what we can do. The problem is we're developing against a closed source operating system. We don't have the source code. We can't edit it. We need to basically bin patch. We need to do hooks. We need to do a lot of work on our end. Yes, I'm in the going to be in the third semester right now at ISS. Oh, thank you. That's it's very much dependent on yourself, how much you can tolerate. So for example, like I have a 2008 Mac Pro under my desk, runs fine for the most part. I don't mind it. But the thing is, of course, I have faster machines I can use. I have proper machines at work and so forth. But for a lot of people, it's the only machine they have. And if they need to run the newer OSs for their software, they don't really have a choice. And so at least they have an option here. Officially, none. They will never acknowledge us. For private support, like the thing is, it's not a company in a sense. It's just individual engineers. We do know engineers use our projects internally for fun, like just on their own personal machines. Also, a good chunk of Apple's Core OS team, at least I know some of them are previous Hackintosh users, and so that's how they transitioned into working for Apple. Unfortunately, yeah, you're running up against like genuine CPU feature limitations. At least for that model, I can't remember when it was dropped. I think it might have been 10.7, or maybe it was El Capitan. Because if it was El Capitan, there's unfortunately no way to patch it forward. Yeah, because on one of the slides, I actually had a whole bunch of other macOS patchers like over the years that have existed, and those ones work for a lot of older machines. So, but yeah, unfortunately for that machine, there's not much you can do. For that 2007, funny enough, you could probably do a CPU upgrade if you want to desolder it. I actually know a friend who can do that, but that's going a bit far. So we never give timelines. Basically, we basically always say 6 months from a release. That's just a random number we throw around. Generally, it's sooner than that, but that's just like for initial testing. We know that people want a number, so we give them a number, but it's not really a genuine number. So within the first day, we of course get the operating system, we download it, we try to boot it first and see, okay, what dies at which stage? Okay, and then we start to slowly backpedal. All right, it died at the bootloader stage. What changed in the bootloader between last year and this year? Start doing like string comparisons. So we'll just like export all the strings into a file, see there. Then we'll also export the function names, see what was added, what was removed, what arguments might have been changed, so on and so forth. And so then just fight on from there and figure out what in the world broke. Oh, that's a good question. So for example, on pre-2012 machines, they are using the OpenGL graphics stack for rendering. And then in 2012, they switched over to the Metal graphics rendering stack. And unfortunately, that means a lot of Metal graphics apps like Final Cut Pro, video editing and such, they won't run on those older machines just because the drivers don't support it. Correct. Yeah. Otherwise, I think that's everything. Thank you so much.